So let's continue to talk about Kafka. This is a Kafka skill channel, and we talk about Kafka replication in syncing. Replica understood how this works. I prepare a quick and simple Docker Compose here that we can start, and you can check the Docker Compose here, right? We will run 3 controllers and 3 Kafka, and you can access this Kafka outside of the box, well, outside of the Docker, or you can execute command inside Docker. I mean, you need just pay attention the way that you want to use. If you want to use via inside Docker, I do this, right? So it's just connect inside the Docker container and execute the commands. That's we created the 3 topics with different replication, right? So I choose 3 partitions, but replication factory topic 1, replication factory 2, 3 for different one, right? You can run from your local machine, but you need to keep in mind to change the port here to not 9092, but you need to put number 2, okay? Or you can take a look here in the container. For example, Kafka 1 is 2, Kafka 3 is 3. I mean, yeah, simple, right? You understood. Okay, let's continue. So what we can do here? The first thing is better to understand the Kafka and the replication. It's to know how the Kafka internals work. So basically, Kafka will create in this container the configuration, the full configuration. Probably you put the Kafka combine logs here, right? So all that you can see my topics created. Create different folders, right? And these folders, what these folders means, this folder means represent the partitions. So topic 1, partition 1, topic 2, partition 0, topic 2, partition 2, topic 3, partition 0, topic 3, partition 2, topic 3, partition 1. So that's it. And these partitions is replicate between the brokers, right? So if we use a Kafka topic, exactly this command, I mean, we can copy paste, it should be better. But inside the container, we need to use 1, right? So we can this way here. Let's just minus describe. If you don't know the commands, you can just execute the binary and they will show some help too, but it's very simple and suggestive. You can just do the describe and you can check how much partitions we have here. I will describe the topic 2 and we will describe it the topic 3. Okay, so let's try to understand a little bit what this means, what these numbers mean, right? So basically, here in the topic 1, we have the topic ID, the number of partitions, and replication factor equal 1. And if you check here, partition 0, validator 6, what 6 means? So this is the number of the node ID. If you check in your Docker Compose, we choose the node ID for each broker. So if the leader of this partition 0 is node 6, which means node 6 is Kafka 3, right? So because we have just one replication factor, one replica, so we can check is replica is 6, leader is 6, and in sync replica is 6 because we have just one, right? And the same for the other ones. But in topic 2 is a different one. So the leader is the broker 4, and replicas, we have a replica to broker 4 and replicas to broker 5. And the in sync replica is good, which means the Kafka replicated well to 4 and 5 to partition 0, right? So the same for partition 1, same for partition 2. And top key 3, we have the similar thing. So leader for the partition 0, it's 4, is node 4, right? And the replicas, we have the replicas for partition 0 on the broker 4, broker 5, and broker 6. And the in-sync replica works well. So what is the important thing here? I tried to explain the last video. When one producer or consumer want to produce a messages to Kafka, they have some acknowledged change between producers and Kafka, and they need to know who is the leader of the partitions. In this case, partition 0, the leader of partition 0 is node 4, which means producer will start to talk with brokers, and broker send a message to producer, hey producer, you need to choose and start to produce your messages because the partition 0 is in broker 4, so this is the broker that we need, you will start to produce a message. It works this way, and so we have a close connection between the producer and leader of the partition 0, in this case node 4. It's the same for all the other partitions, right? So this is, you need to understand this part. It's something that uh, you can see, for example, in the Kafka administration uh, perspective. It's important to know how this works. So I mean, but I would like to simulate something, some trouble, some problems that we can face. What's happen if some brokers go down? Probably you can see the in-sync replicas not work well, under replication partitions. In Kafka topics, we have, example, you can see here under replication partition, under min in-sync replica, unavailable partitions. So sometimes you can see that partitions can be offline, and some partitions not, it's under replicate, right? Which means is a different way. Partitions offline because some broker probably going down, and partition under replicated, it's because Kafka cannot replicate between brokers, but the partition exists. Broker, it's health, everything's fine, but for some reason Kafka cannot replicate between one broker to another broker. Could be network problem, could be a storage problem, or could be a topic ID problem. Yeah, this could be happen. I mean, in the past we have some common problem that the topic ID of the partition or of the specific topic is different in the metadata file inside the storage, and in Zookeeper is another topic ID. So the Kafka cannot replicate between brokers because we have a different topic ID. And how we can fix this? It's simple. Just delete the metadata topic ID from the local storage, and Kafka automatically will get information from Zookeeper and update. Yeah. But I mean, we can try to simulate this. I'm not remember how we can, but you can think in the next video to do this. But let's try to do different thing here. I will delete now a broker, right? Let's go to our README, and I put this. So I will delete and remove the Docker compose. So Docker Kafka 2. Let's try to do this way. Docker PS. So as you can see, we have a different stop key here. Kafka 1, 2, 3, and I will delete. Let me, I will prepare before because I want to check at the same time the Kafka describe. I want to do this Kafka describe. Describe. Okay, yeah, I have them in my path, right? This is why I can execute without needing to specify. You can do this in your local terminal Very simple. So yeah, we have the describe command prepare here, and now I will delete this topic. Just not yes, not have this 0. I need, let's fix this. And I will update my GitHub with all the commands. You can try to reproduce this exactly the same commands in your local machine. So I remove. Let's try to describe topic 3. Let's try to describe topic 2, and we can start to see some errors. And let's okay. Topic 1, topic 2, and topic 3. Okay, good. And Docker, yes. Yeah, so right now we have only 2 Kafka works, right? We don't have a more Kafka. Let's try to understand what happened here. So in the Kafka topic 1, now I have an in partition 0, the leader is 6. And in partition 2, the leader is none. I don't have any leader here. Why? Because the replica is broker 5, and broker 5 is exactly the broker that we delete, which means no leader more here. No data, they cannot survive with this one here. This is why when it's important to configure the replication factor, right? Because if replicas survivor, if it's I mean, for example, let's go to the another example, the topic 2. The topic 2, because topic 2 have 2 replicas, they can survive of it, because topic Kafka 5 goes down, but Kafka can elect a new leader, right? So in this case here, attention, this is a good example here. So now the leader of partition 0, 1, and 2, it's 4, 6, and 6. Because the replicas for partition 1, we have a broker 5 and broker 6. In the replica for partition 0, we have a broker 4 and broker 5. Now the in-sync replica is just 4, the in-sync replica is just 6, right? Because broker 5 goes down. But because broker 5 goes down, Kafka automatically rebalance the partitions, and because all the things in sync, a new partition, a new broker can assume as a leader of the partition. So in this case, leader is the partition, is broker 4 now, and the leader of partition 1, broker 6, because in sync works well, but we don't have more. And remember, if in your producer configuration you have a min in sync replica equal 3, for example, or equal 2, you can face some issues because we have only one broker here in sync. You don't have a 2 or you don't have a 3. So this is important to you know and understood, right? And here in topic 3, we have the same scenario, but in this case, broker 3, we have more replicas, and they can survive better, right? If you want broker growing down. So if you want a Kafka reliable with and prepare with distributed mode, we need to think about how you manage your replicas. It's normally in the Kafka, the main part will configure replication equal 3, or sometimes equal to when we have a biggest clusters and you have a lot of messages between the brokers. Sometimes could be better performance when you reduce it to 2 replication equal 2, because you don't have so much message or so much gigabytes or terabytes to replicate between brokers, and this can cost to you, right? And you can change the strategy that you have in your broker. But it's normally we use replicator factor equal 3. but depends of the scenario. You need to know what's the best option to you, right? Because sometimes producers, for example, need mean sync replica equal 2 or 3, and but you need more low latency or durability or high availability. Depends what your scenario, what do you want in your Kafka. And this is a kind of thing we can discuss more and better. But here we have a good scenario to try to explain a little bit about partitions, leaders, replicas, and in-sync replicas. So if you have any question, please, you can use and comment and try to send the messages and contribute. Thank you.